In this video, I am going to talk to you about box and whisker plots, also known as box plots. So whenever you hear box and whisker plots, it's talking about box plots. And then one way to remember is, right here we have a cat, and it has its whiskers, which this is what a box plot looks like. Alright, so what is a box plot? So a box plot is a display that shows how the values in a data set are spread out. And now one of the things that we need to know is quartiles. So a box and whisker plot shows how a data set is spread out. You can divide a box and whisker plot into, we'll think quartiles or quarters. How many quarters are in a dollar? 4. So that means we can divide it into 4 quartiles or 4 sections. So then if we have 4 sections, each quartile would represent what percent of the data? 25. Because each quarter represents 25 cents of a dollar, right? 1/4 of a dollar. So that would represent 1/4 of the box and whisker plot. So here I have a box and whisker plot. And that means each section represents 25%. So we know it's divided into 4 sections. So from here to here, this is right in the middle. So this represents 50. So if this is 50, what are these 2 sections going to equal to? So this would be 25%, and this would be 25%. So then this would be 25%, and this would be 25%. Now, you might be wondering, how can this one be 25% and also this one if they're not the same size? Well, we're talking about the data. The data here represents 25%. The data here also represents 25% of the data. Now let's talk about the 5-number summary. So looking at a box plot, there's 5 different numbers that you can get from it just by looking at it. Now the easiest ones are the one all the way to the left and all the way to the right. These will be your minimum, which is the least. And then off to the right, we will have our maximum, which is the greatest. So now the other one that's also easy to remember is the middle. Now we talked about a word that represents the middle, and it starts with an M. That is our median, which is the middle. So whatever dot this falls on, that would be our median. Now the other 2 are the tricky ones. So we got the left side of our box and the right side of the box. Now these 2 will be very important to find something else. So on the left side of our box would be the lower quartile. Think lower left side of the box. And now the lower quartile is the median of the lower half. And it might not make sense now, but it will later on. And then the right side of my box, so this is the left, which is lower. The right side will be the upper quartile. And this would be the median of the upper half. Now, 2 other names for these, or abbreviations. For the lower quartile, you may also see it as LQ, And for upper quartile, you may also see it as UQ. Just remember that LQ means lower quartile, UQ means upper quartile. Alright, so we're going to go ahead and review a little bit more information, and then we're going to look at our problem ourselves. So the first thing will be our definition, and we already talked about it. A box plot is a display that shows how the values in a data set are spread out. And then this is something new. This we have not talked about. So the IQR stands for the interquartile range. Now, some of you may remember this or seeing IQR somewhere in my room. If you remember where you saw this in my room, send me a message through Odyssey and let me know. You'll get 5 bonus points on this lesson on box plots. If you can tell me where in my room have you seen IQR, send me a message explaining where, and I will give you 5 extra points on this lesson. Now, to find the IQR, or the interquartile range, you need to subtract the upper quartile minus the lower quartile. And then a way to remember this is, well, we have the word range in here, and we know the range is the highest minus the lowest. So here, we're talking about the quartiles, so we're going to be subtracting the upper and the lower. And it's pretty simple. Alright, now let's review some of the values. To make a box plot, first we need to find the 5 values. And we just talked about them. We need the least value, which is also known as the minimum. And then after that one, if we have our box plot, and here we have our box plot, the first dot we see is the minimum. Then what do we call the left side of the box? The left side represents the lower quartile, or the LQ. And then in the middle, which is the little line, that represents the median. And the median is right in the middle of our box. And then after the median, we have the right side of the box, which represents the upper quartile, also known as UQ. And then we have the greatest value all the way to the right, which is the maximum. Right, so let's review really quick what the lower quartile and upper quartile values are. The lower quartile is the median of the lower half of the data. And then the upper quartile is the median of the upper half of the data. Alright, so now let's look at our example. So here we have some data. We have 25, 28, 30, 35, 38, 42, and 46. So always, the first thing we need to notice is if they are in order from least to greatest. So here they already put them in order, so we don't need to worry about it now. So then the first two things you can right away take from this data is the minimum and maximum. What is the smallest number and what is the biggest number? So 25 would be the least value, and 46 would be the greatest. Also known as the minimum and maximum. Now the median, remember we talked about this already. We want to find the number in the middle. First thing, check the order. Well, they're already in order from least to greatest. Now we need to find a number in the middle. So I'm going to cover up one from the front, one from the back, one from the front, one from the back, front, back. So we end up with 35. So this will represent the median. And notice how my line in my box plot is right at 35. Same thing with my minimum and maximum. My minimum was 25, so my dot was at 25. My greatest was 46, so it's right at 46. And be careful and always pay attention to what they are counting by. Here they're counting by twos. So now we're going to look at the left side of the box, and we know the left side of the box represents the lower quartile, or the LQ. So then if this is the lower, then the right side would be the upper quartile. And another way to write these would be the UQ and the LQ. So now very quickly, let's go over the IQR. We know the IQR is the inner quartile range, and whenever we see range, we know we're going to subtract. So if we look up here, we know that the IQR, we subtract the upper Q minus the LQ. So that's what we're going to do. So on our graph, to find the IQR equals the UQ minus the LQ. So if I look for my UQ represents 40. And then my LQ represents 30. So 40 minus 30 would give me 10. So the inner quartile range would be 10. Another way to remember this, the IQR represents the box. So what is the length of the whole box? So the IQR is all of this. So what is the length of the box? So if it goes from 30 to 40, it would be 10. Right, so I'm going to go ahead and now work an example from your lesson online. Feel free to work this out with me, and then you can go ahead and save your answers and go type them in on the computer. Alright, so this is one of the problems on your lesson. I'm not going to tell you which one. Either way, it's going to be different than yours. So I have find each value of the 5-number summary for this set of data. Alright, so I have 46, 19, 38, 27, 12, 38, and 51. And the first thing I'm going to look to see is if they are in order. Clearly they're not in order, so I'm going to go ahead and rewrite them in order to make my job easier. So first one would be 12, and I'm going to cross them out as I go. Then the next one would be 19, and then 27, and then 38, and then 38 again, 46, and 51. Now I'm going to go back and count how many numbers I started with and how many numbers did I rewrite. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I'm good. I didn't miss any. Alright, so on my problem it's asking for the 5 numbers, which are the minimum, maximum, median, and then the upper Q and lower Q. So the first two that I can get right away are the minimum and the maximum. Remember, the minimum is the smallest, which is 12, and the maximum is the biggest, which is 51. Alright, then the next one I can go ahead and find is the median. Now the median, I like to cross them out as I go, or I'm just going to use my fingers. Cover one from the front, one from the back. One from the front, one from the back, and the next. So then I end up with 38 right in the middle. And then we have the upper quartile, and the lower quartile. So the upper quartile means whatever's to the right side of the median. So we're looking at these 3 numbers. And then remember the UQ upper quartile is the median of the upper half. So what would be the median of these 3 numbers? And that would be 46, because this is right in the middle. And then the lower quartile would be the median of the lower half, which is the left side, and the median of that would be 19. And that is it. We don't have to add, subtract, do any math. Alright, so I'm going to do one more example from your lesson. Use the data to find the upper quartile value. So we have movie ticket fees at a local theater. And there's 6 different amounts. So I'm going to go ahead and first thing, I know I need to list them in order from least to greatest. So as I'm looking at the chart, I'm going to go ahead and write them in. So the smallest one I see is 6.50, or I can just do 6.5, it doesn't matter. Then the next one would be $8.75, $9.75, $10.25, 11, and 12.75. So we're looking for the upper quartile, and we know the upper quartile is the median of the upper half. So what I'm going to do is I'm going to split my data in half. Well, I need to know how many numbers are included in my data so that I can split it in half. So I have 1, 2, 3, 4, 5, 6. So half of that would be 3. So 1, 2, 3, that would be my lower quartile. And then the 3 highest would be my upper quartile. So then we want to know the median of the upper quartile. So that means I'm focusing on the right side. And the median would be 11 because it's right in the middle. Now let's go back to the top one for a minute. So if I were to have this problem and it were to have asked what is the upper quartile for this one, well, here we counted to see how many numbers were in our data and we split it in half. Well, here if I count them, 1, 2, 3, 4, 5, 6, 7, I have 7, but I can't split 7 in half. So then what I would have to do is get my median first and then focus on the right side. Here I don't need to find my median because I'm able to split it in half because I had 6. And 6 is divisible by 2.